నేను కూడా చూస్తాను.
జూమ్ మీటింగ్ మ్యూట్ చేసేసి
వస్తుంది. విజయ్ హలో విజయ్.
సార్ కంగ్రాచులేషన్స్.
హలో విజయ్.
డైరెక్ట్ లైన్ ఆఫ్ సైట్.
హలో హలో విజయ్. స్లైడ్ పెట్టినా కూడా సౌండ్ వస్తుంది, చూసుకో ఒకసారి. అలా చేస్తారా తీసేయాలి. and the online publicity. Friends, we have got together in this hall today to celebrate the National Science Day and the award, Indian Geophysical Dr. NARIAN Lifetime Achievement Award lecture by Professor Sk Tandon. So I welcome you all to this event, and to begin with, I request our director, Dr. V.M. Tiwari, to accompany chief guest, our Professor Sk Tandon, to the dais, please. I request Ms. Samina to welcome them with bouquet of flowers from our own garden of NGRI. Thank you, Samina. And from here onwards, to steer the proceedings, I request our director, Dr. V.M. Tiwari. Thank you, sir.
Today's chief guest and Dr. NARIAN Memorial Lifetime Achievement Awardee, Professor Sk Tandon, Professor Harsh Gupta, our former director, my dear colleagues who have joined through virtual media, students and friends. We are gathered today on a very auspicious day of National Science Day, which is being celebrated this year on a theme, Future of Science, Technology and Innovation, Impacts on Education, Skills and Work. It's really a coincidence that today morning itself, Professor Tandon has inaugurated the Skill Development Program of CSIR-National on Advanced Geochemical Data Analysis. And therefore, it had been very apt to have his presence today when he is going to speak with us on a very contemporary topic. We also know that we are today gathered for a region which is not only known in India, but known globally, marking the most advancement of the science at the time of India, when India was not independent India. And therefore, for last several decades, we are celebrating this day to commemorate the achievements made by Sir C.V. Raman on this day, which was recognized by Nobel Prize. There cannot be a better art person in geosciences to be with us on this day than Professor Sk Tandon, who is known nationally through his several scientific contributions, recognitions, and also his recognitions by international community. And one of them, many of may be knowing that when he was knighted by the government of France with the title Chevalier of Order de Palme Academy in 2009. Professor Tandon is a very distinguished scientist who has received Shanti Swarup Bhatnagar Prize and fellow of 3 distinguished academies of India. His work of geological studies particularly over the Shivalik rocks, is well known. There are several contributions of Professor Tandon. I will refrain myself to talk because that will be presented in his citation when the Lifetime Memorial Award is being bestowed to him by the President of IGU, Indian Geophysical Union, Professor Shailesh Nayak today after the award lecture. Sir, we are so delighted and humble as well as thankful to you that you have made this occasion memorable. This day, it was the last function we held in this hall last year. So exactly after 1 year, we are meeting here to celebrate for a very important thing, that is the Science Day, with the distinguished presence of yours. So thank you very much, sir, and we very honored welcome you and looking forward for listening your talk on Anthropocene concept and why does it matter, a topic which connects science, society, and human beings. Thank you very much. Jai Hind.
Good afternoon. It is indeed a pleasure to be here at NJRI in this hall and to be able to speak in front of a very august audience. Thank you, Dr. Tiwari, for enabling this. We have some very senior, distinguished geoscientists in the room, Dr. Harsh Gupta in particular, Dr. Ravi Kumar, Dr. Chandra. And it is a pleasure that one is able to connect physically after this long business of isolation. At the outset, I feel very humbled by the award conferred on me, to Dr. Harinarayan, and achievement of the. I look up to the personality that Dr. Harinarayan was. I feel all more humbled and begin to ask myself, what is it that I have done that I shall carry the memory of this within the country? And I tried to put together talk. I hope whatever is in the heavens be easy for him. Again, my gratitude to the Indian Union, especially to the NJRI, this moment when I feel honored, proud, and humbled at the same time. So let me begin with my tribute to Harinarayan. I don't think that in this institution, in my presence, but for those of the other audience in the online mode, interestingly, the first PhD award in geophysics, he was in the ONGC, and he had the distinction of being the director of, or rather, first director of the Institute of Petroleum Exploration, and then later the director of National Geophysical Research Institute for a long time, 64 to 78, 51 to 83. And then remember that his mind is a very expansive mind. and he concurrently held a position on Surveyor General of India. He was also the Vice Chancellor of the HU, and of course, many other things. Numerous scientific contributions, but most importantly, I think the establishment of a structure in the NGRI that goes back to about 60 years, and which is very largely still existing. So the type of this is what is remarkable. There are, of course, scientific contributions in terms of seismicity maps, in terms of mineral exploration, in terms of airborne surveys, in terms of technology work, in terms of work done on the oil use, of course, exploration for diamonds, and creating people like us, numerous publications, well recognized through the world. Which I owe gratitude to all these three slides, but I particularly for this slide to Dr. Tiwari, for it enabled me to enter the mind of Dr. NARIAN through this slide. Science and technology have to be relevant to our conditions, our present conditions. We need to worry about what is around us, what is happening, and there must be relevance. Our priorities must be clearly defined, and our actions matched with those priorities. I think there is a very profound statement, and that profound statement me to begin to ask myself, what am I doing on this earth? I'm 75 plus, okay, survived Corona until now, of course. And then, of course, the idea came that I should share what was going on in my mind in terms of the Anthropocene concept, or this something which has been kind of a very tantalizing concept, which has debates, divides, but yes, it impacts every single human being. We need to think about it. It is certainly a part of system science, but that it is not not now, this is like 2011, it carried a cover page, welcome to the. So we can see now that, the Anthropocene is something which is way beyond Earth system science. Now, first, one gives credit and pays obeisance is this incident that happened. That's for the Nobel laureate for 1995. He died on the 28th of this year at the age of 57. A remarkable person, and he was attending the IGPP meeting, the scientific committee meeting in Mexico. Actually, was listening to people, and then he was getting irritated, and then said, "Stop using the word Holocene. We are not in the Holocene anymore. We are in the." He was looking for words, and then he said Anthropocene. So this is how the beginnings of the revival of Anthropocene took place in the year 2000. Then it was quiet in the room for a while, and then more recently, of course, after his death, I think it was around the 5th of February last month, that there was this tribute that was paid by two of his colleagues. And I'll read that because it has ramifications as to why this topic is important. His realization that humanity had very recently stumbled into of its own making. I think that is important. The Anthropocene created reverberations that continue to shape not only the world of science, but that of all scholarship. We're going beyond Earth system science, we are going beyond science and into political, economic thought and the fundamental understanding of society. I think I am a bit of a history buff, I don't kind of want to give the entire credit to Paul Crutzen. Way back in time, of course, this idea itself not new, but the revival is certainly attributed to Paul Crutzen. The idea of the Anthropozoic era, and in one page note, yes, Paul Crutzen also acknowledged Antonio Scopini, who actually laid out the fundamental premises of this idea. New telluric force, which in power and universality may be compared to the greater forces of Earth. So this is where we are going, that Earth forces and the forces that humans collectively put together are beginning to match. They are coming on the same kind of scale. And so ultimately, of course, I think this was this one article. It was written by Paul Crutzen in the 2002, if I'm not mistaken, Geology of Mankind. The definition that he laid out at that time was that the Anthropocene started in the late 18th century when analysis get trapped in the beginning of growing global concentration of carbon dioxide. That's where the jump was taking place in terms of what one would see the change in the greenhouse gas chemistry of the atmosphere. Then, of course, I think it just jumped. The concept jumped, and in the last 2 decades, there are kind of, it's impossible to follow the literature, and some of these diagrams, particularly from the Stockholm Resilience Institute and William Steffen and others who have been showing the kind of changes that have taken place in carbon dioxide, in N2O, in the concentration, in ozone depletion, surface temperature, ocean ecosystems, coastal zone, terrestrial ecosystems, and so on. So each one of these, essentially, one thing that needs to be noted here is, although the start of the change in the rate of the systems is around 1800, there is a line which has been drawn at 1950, essentially. That was 1950 AD, and there has been a huge debate now in the last, I think, 2 years particularly, and an ongoing debate, because it has been referred to the International Committee on Stratigraphy, the ICS, and the question that is being asked is that whether Anthropocene should at all be adopted in the stratigraphic chart, in the International Chronostratigraphic chart, essentially, which the ICS brings out as a new standard. Now, let's see what happened 300 years ago. There are 2 arrows on this, which I put. Of course, mechanized farming around 1701, industrial scale use of fossil fuels about 300 years ago again, and then Gregor Mendel and genetics in 1856. These are some 7 landmark events in human history which have begun to change the way our existence is, and has allowed us to come to this particular point, or if you like, prosperity, and to reevaluate our relationship with the later. Okay. Of course, we have the Haber-Bosch process, 1909, the Green Revolution of the 50s, which allowed humans to be fed, and consequently the 7 billion mark crossing in 2011. Okay. So just an illustration that this is one Nobel laureate who, of course, is responsible for finding the word, but the concept of the Anthropocene has also gone into politics, economics, governance, and international law. The concept of the Anthropocene heralds a profound shift in the perception of our place in the world. Centuries from now, the defining event of the 20th century may not be the Great Wars, the battle of ideologies, or even the revolution per se, It may well be the ascendancy of a single species that has to become the dominant geological force in the human lifetime. That's what this political economist, famous one, Elinor Ostrom, said in the conference that they had on Planet Under Pressure. Okay, now let us look at the Earth. The Earth is very old, 4.5 billion years old, and I'll not walk about the kind of, so what is being shown over here is the energy. The Earth, there are no humans for a very time, so even for thinking in Earth, we're talking in terms of energy levels of that kind. And the first time humans made their presence felt in some significant way on Earth was in the use of fire. Right? When man discovered or humans discovered fire essentially, and then of course the energy that was utilized by humans was very, very insignificant. But when does it begin to match? When is it getting close where the terroric forces and the humanity both begin to match over here? And that's where we have a huge energy use in terms of the fossils, so fossil fuels. So, the question still remains as to when do we want to start the Anthropocene. This seems to be a big question as far as earth sciences is concerned in terms of the ICS chronostratigraphic chart. There are, of course, multiple options. We know that the Holocene epoch goes back to 11,700 years, largely according to in terms of the orbital parameters of the Earth. And then the question still remains, where should we put this? Should we put this boundary at 250, at the beginning of the industrial era, or as some would want it even earlier, when the beginnings of agriculture is? Of course, there is a solution whenever there is a problem, and one of the solutions that has been offered is to come from, that's like 1 million years early hominids, you have Neolithic revolution, you have the Industrial Revolution, and you lump all this into the Anthropocene and the acceleration after 1950, when we have the huge jump in the last 15 to 17 years that we could get as the Anthropocene, particularly with respect to the atom bomb in 1940. Now, having introduced what humans have been doing, let me move to an Earth where for the moment, let us think that there are no humans, and that we actually are just looking at Earth, the Earth's surface. By itself, what is happening on the Earth? Humans now, tectonics provides the surface topography platform on which everything happens. On this tectonic platform, essentially tectonics, we have climate operating. Greenhouse feedbacks are a very important aspect. The climate largely is controlled by orbital forcing on geological time scales and the greenhouse feedbacks together. And of course, also the issue of volcanic emissions. Now that gives rise to this interactive system over gives rise to our physical atmosphere, it gives rise to the chemical atmosphere, the two together give rise to the vegetation, and the three together give rise to the physical land surface, the chemical land surface, and then the process of mixing, and then of course your dust fluxes, and then the transfer from the continents to the oceans, and that gives rise to the physical ocean and the chemical ocean. Okay. So we forget about that. That is elementary. On the other side, we've talked about people, and we have people over here. So you have this triangle over here, which is a burgeoning population. We are, whatever, 7.4 billion people now. And what are those people doing? So this expanding triangle over time. And then those people are in energy, those people are in food, and those people are in need. Food, energy, and water. So that's the Earth's surface in this slide, and food in water. This slide essentially, and you can see that because of that, we are now actually changing the hydrological cycle. We have also changed the cycle. So on the Earth surface, we look at the Earth surface as an system, and of course, the question of people. And the moment we talk about people, we need to begin to worry. If you remember, we are about 2 to 3 billion in 60 decades ago. This was the diamond of India, right? In 6 decades, multiplied 2.5 times, right? When India started, the global population was 3 billion. Today, we are approaching 7.5 billion. So within the lifespan of India, right, in 60 years, the population has jumped by 2.5 times. So, now that many people on Earth, so anthropogenic forcing, you have time scales, and one of the very important things at the surface of the Earth is also to be worrying about time scales. So, multiple time scales, these are the time scale in years, 9, etc. But let's come to the red ones, essentially, where we're talking in terms of anthropogenic forcing, which can take place on century scales, as well as on scales, and century scale is all about climate change. And then, of course, there are lots of things that happen at the regional and the local scales, essentially, which can be much shorter. I think that's where we are. A globe which is overpopulated, and a huge amount of activity inside the Earth is happening at the surface of the Earth. So this is the agenda, in a way, for the Anthropocene. And as far as I'm concerned, my worldview goes back largely to the Brotherton diagram. This is a committee to set up Brotherton, who's an atmospheric scientist from the Wisconsin. And I would think that the Brotherton report, in the 80s or so, was the report which actually, this is the Brotherton diagram, which is essentially talking about biological cycling and then systems that are there at the surface of the Earth. What is happening in terms of the water, soil, moisture, marine biodiversity, and all the information that is there. But then, the red thing over here, which is human activities. And that's where it is important. It impacts water, it impacts land use, it impacts greenhouse gases in this planetary machinery diagram, and it impacts climate. Climate change, of course, impacts water, it impacts land use, it impacts greenhouse gases. So now I have picked from here 3 land use, climate change, and hydrology. Through some of the things that have happened in the last few decades, understand what is the first one. Human biodiversity loss. I like this quote which I heard from Y. Murray, Professor of Oxford. Agriculture is colonization. There very little is left actually. And this is that must be this. Okay. Sorry for that minor interruption. So agriculture is the colonization of ecosystems, and we're seeing lush green areas. And agriculture is since the beginnings of civilizations, multiple civilizations, be it Egyptian, be it the Indus Valley, and we're talking in terms of approximately 10,000 years. So that's a long time for in the natural vegetational systems. The problem is, okay, this is, okay. So this is a chart or a map, which is actually about how domesticated crops originated during the early Holocene. 1,000 to 8,200 years, and how these have been dispersed all over the globe, essentially. Okay? And that essentially tells us that today, ecosystem processes are mostly a function of human populations and their ecosystem interactions, rather than being essentially a product of climatic factors. It's humans who are actively controlling the vegetational or the biosphere in terms of the vegetation on the surface of the earth. There's an Indian involved there also, Raman Kurti. And then, of course, there's a very interesting paper which is called The Used Planet, which appeared in FNASc a couple of years ago. It tracks down the way in which parts of the globe have been changed, and instead of calling them biomes, they are in terms of the anthropogenically formed biosphere and use of atoms instead. And you can see, of course, when we look at India, because of heritage and legacy and agricultural practice for these variations, we are very much here in this long period of use. So that much for land use. The next 3 slides are for climate change. Now, as far as climate change is concerned, I think the moment we talk in terms of climate change, we're talking about climate change without talking about the energy climate nexus, and that's what brings us to fossil fuels. And one has to begin to look at fossil fuels first. So we look at the fossil fuels, right? So that is the distribution, of course, of total conventional, then of course conventional to be discovered, the total non-conventional, and the old research. This is important one question today. Both China and India, elsewhere, Australia, and the question is unburnable coal. Economists say that, okay, what is the environmental damage that this coal is going to cause? Can we do that? So there are institutions now, I know that particularly institutions, economists tend to say that, okay, this part is unburnable if you want to keep a safe operating space for humanity. And we can look at the trends as postulated from the natural gas in terms of area of natural gas. That's where we are actually, where we are likely to be, unless there is something very grossly disruptive, that is likely to be in the decades also. Where fossil fuels will become much lower, and solar and hydro and will become more important relatively. So that's the hope, that's the path. But for what has been already done in take-home messages, that we are beyond the envelope of natural variability, and that's where we are with respect to temperature. And that temperature rise is generally attributed to carbon dioxide rise, and look at the natural variability. For those of you who may not have been, this is a very famous diagram. This is 800,000 years, 100,000, 200,000, let me emphasize the ages. For 800,000 years, there was an envelope of variability over here, and that envelope of variability, largely driven by orbital parameters, was between what we call glacial and interglacial cycles, 180 ppmb to 280 or 350. Never before did we cross 250. And now, of course, we are at 480. Okay, so that's the 1950 level when the famous healing Mama started in Hawaii, and where the young man then, now an old man, healing. And you can see that the forward mark stands actually. So, in a sense now, we have looked at agriculture, land use, and the combination of all this together with what has happened in terms of atmospheric greenhouse gas changes in the atmosphere, particularly CO2, and then both from the land use perspective, if somebody wants to go to 7,000 or 8,000 years in terms of the beginnings of agriculture, or even if you want to include the fossil fuel energy time. So these are the two things which have probably impacted, and we brought the concept of the Anthropocene to the fore and asking humans to reevaluate our relationship with the planet. I'll come to a third part because climate and hydrology are very strongly linked. In the beginning, when I showed the diagram, I said I'm going to kind of pick on three elements of this land use, which we talked about briefly in a very general way. Climate change, the essence of the story, in 3 slides. And now I'm going to give you a few slides as far as India is concerned, what I believe is the single most important thing for us is water to our rivers and an understanding of our rivers. So we are very well bestowed. We have had like God's grace in terms of the monsoons, in terms of these years through time essentially. We have really God's grace on us in terms of large rivers, both in Peninsular area as well as in from the Himalaya down. Now, what is worrying is 2019, for instance, newspaper Science doing best was looking at the anthropogenic in the world. The big rivers support 2.7 billion people, one of the most economically vital. In fact, the number was stunning. I was looking at the number, somebody there was like $265 billion a year is the collective dimension as what we benefit economically from it. Anthropogenic stressors include scale damming, hydrological change, pollution, introduction of non-native species, mining. And the worry is that in many of these large aquatic bodies on the terrestrial part of the earth, ocean, we might be setting up irreversible transfer. And for the health of the rivers, and in turn, of course, the health of the human populace, which depends on the rivers. So the big question is, systems, as far as we are concerned, how are in this Godavari, Krishna, and so on. The rivers are also connected to the sea. So the rivers also have something to do with sea level. Well, do not think in terms of sea levels, but the Holocene river flow is a simple balance of precipitation, evapotranspiration, and accounting for transient storage in groundwater, lakes, snow, and ice. The textbook will tell us climate was thus the major driver of Holocene floodplains in the deltas. This is what we teach our undergraduates. But the question is, how can we the movement of water and sediment through the landscape before and since the human footprint became large? So what have humans done to it? And can you quantify that and just the impact? So this is, of course, from the same paper. I'm not expecting you to follow the slide really because there's too much here. And one is just trying to point out that a lot of the stressors have actually been put out against the first one. Of course, discharge, habitats, ecology, so on, right? So stressors, I mean, for some of you may wish to go back to this original study. Okay. Now, just to make the impact, could you the little movie, so for about 30 seconds or so, it's working, okay. So I would urge you to look at how the dam since 1800, in the last 200 plus years, how this is out. Focus here, here, focus here, focus here. Okay, so we've seen, and look at that actually. Oh, why should it move again? Again, it goes away. So I pulled out that. See a bit of the dams there. You can see America. This is also shown as a movie. I don't have it. It is from 1800 to it was all white. And in 2003, that is the situation. This is coming from Colorado setup over there. The reservoir was more than 2.3 gigatons per year, less sediment to reach the coast worldwide. Now that has a huge implication on sea level and the way the coasts are going to be inundated actually. So reservoir toxicity. A very interesting study actually, where if you look at the summary of this kind of change that has taken place through time, you can see that that is about the annual sediment load to the sea against the millennial time scale, and then of course there's a break in the time scale here, and what is plotted towards the right side is the decadal time scale. And you can look at numbers when we are back in time at several thousand years ago. That was the kind of annual sediment load. Then, of course, human activity caused a change, right? And that was in the last 1,000 years or so. In response largely to the increasing population, agriculture, all of that had got increased essentially. There again, human footprint is seen again from 1950 onwards, then to the past, right? And you're coming to similar levels as they prevailed several millennia ago. So interesting stories if you try and track change through time. Actually, of course, this is for the five big rivers in Southeast Asia and East Asia, Yellow River, say, Pearl, Red River, and the way things have changed from the 1950s over these years, essentially. Now, that has very, very serious implications as far as sea level is. What is the amount that is going? And without going into the details, essentially, we'll point out this one. This is the scale on elevation. This is negative, minus 800 millimeters, minus 400, and minus 200. And we can see the increase negative on the right? And so also on the number of I don't think we can sit back, watch these things take over in the next 5 years. Unless we have a very strong proper plan today and thinking about this, at least, I think, we are not honestly preparing ourselves very strongly for the future. Now, finally, I thought I'll put in a little bit of one Anthropocene incident in which I was involved. What happened in the Kosi Fan in North Bihar, a very major flood which actually disrupted the lives of about 500,000 people, happened in August 2008. And the book written, which has a very nice title, Trapped, the Devil and Deep Waters, and then this is the Kosi over here. And what did we do to vent its fury on us? Now that's the Kosi over there. The Kosi is a natural avulsive system which has moved about westward shift of 100 kilometers into it's a naturally avulsing system. Now what we did in 1955-56 was this naturally avulsing system was straitjacketed. We created an embankment, eastern embankment and a western embankment, and locked that fire in about 5 kilometers stretch. Actually, what used to kind of have the span of 100 kilometers, we locked that. And then, of course, a lot of network, other things, water logging, many things began to happen. population density accompanying anthropogenic disturbances, railroad network, what was with a system which of course was not taken into account, but it's a high avulsing frequency coupled to all people from IIT Roorkee, Gade, and some hydrology stalwarts had talked about it as an avulsing system. And then of course it has led to severe. So what happened on 18th August 2008 was that the embankment breach took place 12 kilometers upstream of a barrage, actually. Embankment breach grew in 3 days from a few meters to 100 meters. So 1500 meters long breach that developed over a few days and resulted in a sheet 15 to 20 kilometers wide and 150 kilometers long, with a velocity which of course was 1 meter per second, and also a channel bed elevation which was higher for the river, so it had the potential energy, and there was a maximum eastward lateral shift of about 100%. So although it had nothing to do with the barrage, right? The barrage had enough capacity there actually, but upstream of the barrage, the embankment failure took place, and 4.8 lakhs, 500,000 people were impacted by that. So we asked the question, how did the hydrological flux get connected to the newly formed river? Where did it go? Prior to the avulsion event, this terrain mostly consisted of small seepage channels near the embankment. But there's also one major seepage channel in the avulsion system, which was reoccupied. So whenever there is a pause, it's my, this technology that's telling me. So this is where it was. And this is where the river jumped out, actually, and then flowed into the terrain. Right? So that was post-avulsion, that is the pre-avulsion framework, that is the post-avulsion. New channel, 100 kilometers away. And of course, some very detailed work has appeared more recently. But this is work that we did earlier. So we asked ourselves the question, is there adequate connectivity information embedded in the digital elevation model to be able to forecast the major flow paths and obtain an approximation of the inundation? For instance, if we knew already that this is where the waters are going to go, then that population of 4.8 lakh that was impacted, we could have made that much more, kind of disaster could have been averted. Could have been averted if the embankment failure had not taken place and the embankment maintenance had kept up proper pace. So then, of course, we took a topography-driven channel connectivity from the Swaha into the avulsion base. We used essentially the methodology of change detection using Landsat imageries, and then compared this with the pre and post avulsion channel network connectivity. And finally, actually came up with a model which actually, more or less predicted 70 to 80%. So even from the 2000 data, if we knew that the embankment breach is going to take place, we could have predicted and said, okay, this is going to be our approximate inundation. So whatever had been built over there, maybe that should not have been built in that zone essentially. So that was one thing. And then, of course, this got published in Geology in 2013. So that's the third example from the hydrology cycle. Now, why have I been talking about all these things? Now let me come to the third part of the talk. The third part of the talk is essentially trying to tell us that, look, we may laugh our guts off saying that, okay, geologists talk about 2 million years, 20 million years, 200 million years, 200 million years. How is it relevant? So interestingly, there was a book called Timefulness. And look at the subtitle of that. How thinking like a geologist can help save the world. Right? So I think the lessons essentially here is that much has happened in the geological past, and if we can kind of extract that information and begin to apply it usefully to our existence in the Anthropocene, we will be better off. There is much to learn. So I think that is the message that book is trying to convey. And with that, I'll come to planetary boundaries, because now all of this essentially is aggregating to telling us that, look, in the Anthropocene, we are 7.5 billion people, we are racing towards mid-century, and 30 years from now, we will be 89 billion people, that's the estimate. So then there are, of course, economic models about carrying capacity, about limits to growth, about guardrails, about tipping points of major ecosystems across the world. So the idea of a safe operating space for humanity has been put forth by the people from the Stockholm Resilience Institute, Jan Strong in particular, and it is captured sometimes in very small titles. Big World, Small Planet is the name of the book which Strong wrote, which is about 200 odd pages. And Is the Planet Full? Another book in golden century. And they are talking largely in terms of whether we've crossed or getting to cross the climate, the safe operating space in climate change, in northern cities, in stratospheric ozone depletion. Where are we with respect to ocean acidification, with respect to phosphorus, nitrogen, freshwater consumption, land use change? And this, I think, is a paper which appeared in FNASc in 2018 on the trajectories of the Earth system in the Anthropocene. So what we have looked at so far is essentially stability, the cold to hot on this side, and then this is the glacial interglacial limit cycle. If you remember, I showed you the carbon dioxide diagram in which I said that for 800,000 years, carbon dioxide has ranged to a state in 180 ppm to 250 ppm. This is that limiting cycle. This is where it gets limited. We have gone beyond that. Once we have gone beyond that, the Earth now is believed to be sitting here essentially, and we could be here now, and human emissions and the Earth system stewardship is what people are talking about. We cross a planetary threshold, we would have gone ourselves, we would have pulled ourselves into a basin attractor, never to come out actually, and for centuries and millennia people believe that, or even tens of thousands of years, we won't be able to come back to the situation. However, I mean, if there is an intelligent way of looking at things of our negotiations with the Earth in this century, then yes, we might come back. So this is, I think, a very influential paper, which was written 2 years ago by about 20 authors, led by Sk Tandon. So now, let me begin to conclude. Who are we? We are living in an Anthropocene world. We are the first generations with the intensity of economic development that our presence is starting to be felt by the planet's total. We have lived up to the text that was written in 1873 by Antonio Stefani, right? First generations to understand the collective impact of our collective actions through millions. First generations with opportunity to redefine our relationship with the planet. This is what we look like in the social distancing. So, this is where we are coming from. Homo sapiens out of Africa, migrations on the Great Acceleration 1950. And then, of course, the planetary boundaries, which we have just now spoken about. The issue of whether we will get into the basin, right? Basins always are attractors in terms of potential energy. You end up in the basin. Or if we kind of worry about keeping ourselves below 2 degrees centigrade, then, of course, we may end up in the safe Anthropocene. Or at least something like the good Anthropocene is something we could aim for. Now let's look at the Anthropocene in India. Do we talk about the Anthropocene in India? You know, very little talk about the Anthropocene. I don't know why, but then I tried to kind of dig into the literature, and over the last few days, I got a student of mine, or colleague of mine now, to look at what is available. One of the books that attracted my attention was, of course, Dr. Rajivan and Shailesh Naik's edited volume on observed climate variability and changes. And they have been looking at century scale changes in a lot of the parameters like rainfall, temperature, SST anomalies, and so on. So there is some bit of information as far and data is available as far as the last month is concerned, particularly in the domain of climate. Then I said, okay, the other thing that I was worried about was land use. Has anybody analyzed land use and land cover change data over 100 years? So I asked myself that. So land use and land cover change, agriculture, forest, built up, and then this is grasslands and shrublands essentially. So that is the built up, how it is increasing essentially. This is the grasslands, this is the forest, and that of course has to be agriculture. Population and built up, there has to be a correlation in these two. So these are along expected lines, and that was this interesting paper in which of course Dadwal, Vicky Dadwal is also an author there essentially. So we have some data on land use and land cover also. It's not as though we don't have that. And some other. And then, of course, we have data on extreme events in the Anthropocene. And I think I don't need to remind this audience here, essentially, everybody knows about what has been happening in the last 60 years. There have been papers also from the IITM group, etc., on extreme events. And we know the consequences also in terms of both Bombay and Chennai and Kerala more recently. And of course, the Uttarakhand deluge and the Kedarnath deluge of 2013. And then, of course, the Leh deluge of 2010. All indicators of Anthropocene change. So where does that leave us, essentially? So today, people are no longer talking about, I mean, it is already difficult when you want to combine geobiology and exchange all these things. So that itself is very difficult. So Earth system models, of course, but remember that if we have to be in the safe and just space for humanity, if we have to have safe operating space in India, essentially, then we need to look at all of this because we have to fulfill these needs. At the same time, we cannot lose track of climate change, ocean acidification, chemical pollution, nitrogen and phosphorus loading, freshwater withdrawals, name it, and you have it actually. So you can't run away from this. So the integration. So when you begin to talk about integration, in the last 4 or 5 years, a lot of people have begun to talk in terms of looking at different taxons of models. Here, of course, unfortunately, geophysical is not mentioned, but it incorporates it within the biophysical, socio-metabolic, and socio-cultural, essentially. And then, of course, cultural, the human flows, what we take from nature, what we put out as waste, and how we recycle it, that, and of course, the natural environmental flows, essentially. So there's a whole lot of kind of activity now in trying to couple these into social environmental kind of models. Although that's just the beginning, but I think it's time for us to also. So, Earth system dynamics of the Anthropocene, that is an activity that we need to undertake. Biosphere tipping points in the World Earth model, and we need to worry about our own biosphere tipping points, particularly in our biodiversity hotspots. Social tipping points, very complex because we have to do the handshake with the social scientists. And then, of course, it creates scenarios for 2050, 2100, and keep playing the Earth with events. Okay. So with that, I have 2 more slides. I jumped one. Oh. Okay. So I think time is there today for starting something in Anthropocene. How we started, whether we have the finances, whether we have the will to start it, but a virtual center for Anthropocene research is not too much to ask for, which looks at geological, geophysical flows, looks at the biophysical flows. A small step has already been taken in terms of the critical zone observatories, which have been put into place. We've got biogeochemical, biogeophysical, which will go into the Earth surface models. We can provide information to the global scale, but we should be more importantly looking at our own regions, particularly the climatic zones in India. And then, of course, looking at our population statistics and the way material and energy and matter flows we have kind of used in our systems, this socio-metabolic tecton, and then of course the issue of the cultural, long-term cultural issues. So there are these three issues. And then of course I think the first thing to do is to set up a virtual center, get collaboration mode with IITM, NRSA, NGRI, DD, NIO, and CSIR all together essentially. A lot of AI and machine learning expertise will be required, and we should be looking at future trajectories of the next decade, the 2 decades, 3 decades, and 2100 AD, and then feed into policy. The next slide gives us some view of what we have done on the critical zone observatories. So with respect to the previous slide, I think there is a little small step that has already been taken. We have these 12 CSIRs. The last 4 or 5 years have either started functioning or initiated efforts in implementation. And the main aim is to understand the interaction between biotic and abiotic processes in different environments. So I think there is some little bit of activity there already. And the last slide is telling us that we must, at this stage, pause and keep worrying about how to negotiate with the Earth. Let us not make the assumption that the Earth is going to, is boundlessly going to give you space. Thank you very much.
So generally, on this lifetime achievement award, we don't take questions, but last time, the same award lecture, Professor Gaur had started at, no, that's a, and there are several senior colleagues who have joined online. I just received message from Professor D.M. Banerjee that they have some remarks to make and would like to speak. So would you like to take 1 or 2 questions? So we can have 1 or 2 questions. Anybody else? Online. Okay.
Well, first of all, very thought-provoking and very difficult and the basic point is importance of the scientific importance of earth sciences.
Yeah.
But somehow, in spite of all of our efforts, is not getting implemented. And that is something which is really very good. And I'm sure that we will be studying on it and continue. But on the other side of the coin, I think we try to say when did Anthropocene really started. So I said that the very appearance of the mankind put the beginning of man, because as you rightly said, that the discovery of fire, etc., when the start process started and now we are in such a state. It also at times intrigues me that there have been mass extinctions in the past.
So there will be 5 months.
And these mass extinctions are not predictable.
Yes.
It could happen tomorrow. So that takes care of all of them.
Chance. Leave it to chance, a meteorite impact.
But still, I think the points that you have made are very, very significant, and the way the camps that created health. I mean, all the floods in the Himalaya are magnet floods. So I sincerely hope that the youngsters catch up on this. And I just want to compliment you.
Thank you.
Yeah, I think Professor RN Singh ji is online. Sir, do you want to ask something? Some question? Professor RN Singh, sir?
No, I don't have any question.
Okay, thank you, sir. Thank you, Professor Sk Tandon, sir. It was really, you have elucidated all the gamuts of the newest time scale, we can say, Anthropocene. The next item on the agenda of this event is to felicitate Professor Sk Tandon by the President, Indian Geophysical Union, Professor Salesh Nayak ji. May I request Professor Salesh Nayak ji to read the citation, please? I think he's online. Yeah, I think we have some connectivity issue. So till Professor Salesh Nayak ji joins, I request Secretary IG Dr. Abhiram Bansal to read the citation, please.
Good evening, Professor Sk Tandon, Dr. Sk Gupta, Dr. VM Tiwari, and my dear colleagues. It's my pleasure duty to read the citation of IISER Harinarayan Lifetime Achievement Award 2020. Professor Sampath Kumar Tandon, born on 13th August 1945. Presently, Professor Tandon is Sir J.C. Bose Chair Professor and Visiting Professor at IISER Bhopal. Has devoted more than 50 years toward teaching, training, and researches in geosciences and provided services to the society. He has made outstanding contribution in physical stratigraphy and sedimentology, geomorphology, and quaternary geology with reference to the Indian region. He initiated the application of physical dating methods, magnetic polarity, luminescent dating, and fission track dating of zircons to Neogene and quaternary continental sequences in part of Himalayan and Western India. He contributed significantly for reconstruction of late Cretaceous paleogeography of central India. These studies highlighted the influence of Deccan volcanism on contemporary sedimentary environments. He worked extensively on the application of calcrete and related phases to advance the understanding of Phanerozoic stratigraphy records in India, Scotland, and Canada. He made extensive studies on the responses of late quaternary fluvial system and shift in monsoonal precipitation and the tectonic geomorphology of a part of the Himalayan front. He has edited several books and thematic journals, issues, and authors more than 100 research papers, being chairman and member of several advisory committees. He has formulated several science programs and educational curricula for the growth of Indian geosciences. He is a notable academician, able administrator, and exceptional researcher. Professor Tandon has made anonymously chosen for the IG Harinarayan Lifetime Achievement Award for the year 2020. I request Dr. VM Tiwari, Vice President of Indian Geophysical Union, to honor him with an Harinarayan Lifetime Achievement Award.
behalf of IGU and President IGU. Citation.
Now I will read the citation of IGU Decennial Award 2020, which goes to Dr. Csir-Ngri, Chief Scientist, CSIR NGRI, is the head of seismology and has made significant contribution in the field of seismology. His major initiative was to strengthen the seismological network around the country with the objective to study the source processes, image Earth's deep interior, and assessment of earthquake hazard. More than 250 broadband seismological stations are in operation in various regions of the India. That's the big achievement. These helped in mapping the seismicity active faults both in interplate and intraplate scenario and focal mechanism, in understanding the seismotectonic of the region, and provided necessary input for the assessing earthquake hazard for setting of critical and vital installations such as nuclear power plants, bridges and dams. The Indo-Gangetic Plain network helped in determination of sedimentary thickness, responsible in amplification of ground motion due to earthquake in Himalaya, and resulted in proposing the first ground motion prediction equation for this region. The teleseismic earthquake helped in mapping the lithosphere structure and mental anisotropy under various geological provinces. He applied tomographic techniques to map the lithospheric structure of South India and seismologically active Koyna-Varna region. Under the outreach program on the earthquake safety, the seismological stations were set up in various schools located in Uttar Pradesh, Maharashtra, Uttarakhand, Telangana, and Andhra Pradesh to sensitize the school children about earthquake and precaution to be taken during the earthquake. I request Dr. V.M. Tiwari, President of IISER, to honor Dr. Csir-Ngri with IISER Decennial Award.
On behalf of IGU and President IGU.
Thank you very much, Dr. Tiwari ji. And I request Professor Salesh Nayak ji if to make your remarks, please. Presidential remarks from IGU. Professor Salesh Nayak ji, please. Sir, please unmute yourself.
Sorry, I could not join because some other meeting came up in between. And my heartiest congratulations to Dr. Tandon and Nagesh. My heartiest congratulations. And I think I missed the talk by Dr. Tandon, which would have been really worth. And I request him, please excuse me for not being present. Unfortunately, with Chairman Niti Aayog, meeting came up suddenly, and I had to remain present. So this is what happened, and I wish very best to all of you. And thank you very much. Thank you.
Thank you very much, Professor Shailesh Nayak ji. And as this event of National Science Day, it is our pleasant duty to honor Professor Tandon with a token of affection. And I request Professor Tiwari to do this pleasant duty. Thank you. Thank you very much, sir. And now I request Dr. Kirti Srivastava to please offer a formal vote of thanks. Dr. Kirti Srivastava, please.
Today it's a great pleasure to have you, Professor Tandon, here with us in NGRI and to deliver Professor Harinarayan's lecture, lifetime lecture. And let me tell you, he was a founder of NGRI, as you showed his pictures and all. And one of the pillars is sitting with us, Dr. H.K. Gupta. Thanks to all of you, you all made NGRI what it is. And we have the present director, Dr. Tiwari, and we have all these people who have worked together, put their might and souls in the building of this prestigious institute, NGRI. So my homage and my prayers for Professor Narayan, that his soul, wherever it be, may it rest in peace. And sir, what an apt talk you gave today, Anthropocene. And let me tell you, we are all looking, we know what is happening today on the earth, all the extreme events and all these things. And we all need to take these problems as challenges and try to work for it. And this is for all the youngsters that you had Professor Sk Tandon with you all to deliver such a apt talk today. And all of us know what is happening in and around today, whether it be climate change or any extreme events. And thank you very much to bring in this new topic today to all of us. Thank you so much. And thanks one and all for watching. And thanks to many of our RC members who are watching from there, many of the Professor Harinarayan students and their colleagues who are watching. I heard Dr. Arun Singh's name then. And Professor Shailesh Nayak, thank you so much for being there online. I think next time we should have you here in NGRI. And Professor Sk Tandon has started the new trend of coming. And let's hope for the best that the COVID goes away soon, so that next time again this hall is full blooming with people. Let's hope and pray for the best. Thank you one and all. Congratulations to Dr. Nagesh for his award. and congratulations to this. I completely forgot. I didn't know you were not sitting here. You went somewhere. I mean,